Hi everyone, it's Mrs. Summer here. I am here to talk about lesson 105, solving multi-step linear equations with variables on both sides. In this lesson, students will be able to solve multi-step linear equations with variables on both sides of the equal sign. They will also be able to determine whether an equation has infinitely many solutions, no solution, or only one solution. Recall, we can solve a multi-step equation with distribution by distributing the constant to everything inside the grouping symbol, combining the like terms, using the opposite of a constant property to get the term with the variable by itself, then using the reciprocal of a coefficient to solve. An example of solving an equation with the variables on both sides is this equation. Solve for k. Negative 4k plus 2 times the quantity of 5k minus 6 is equal to negative 3k minus 39. What I'm going to do first is I'm going to distribute the 2 to everything inside the grouping symbol. So I'm left with negative 4k plus 10k minus 12 is equal to negative 3k minus 39. I'm then going to combine my like terms. So I'm left with 6k minus 12 is equal to negative 3k minus 39. Now what I'm going to do, because I have variables on both sides, I want to try to get my variables on the left-hand side of the equal sign. Sometimes that doesn't work, it's not the easiest way. But in this case, I'm going to try that. How I'm going to do that is I'm going to add the opposite of the term negative 3k to both sides of the equation. So I'm left with 9k minus 12 is equal to negative 39. Now I'm going to add the opposite of my constant to both sides. I am left with 9k is equal to negative 27. Now I'm going to divide each side by 9, and I'm left with x is equal to negative 3. So here is the work, much neater than my own handwriting. So what I did first was I distributed the constant. Then I combined my like terms. In this case, I added my opposite of my constant. In the previous example, I added the opposite of my term. Either way will work. Then you simplify. I used my opposite of a term. I then used my reciprocal of a coefficient. I simplified to get k is equal to negative 3. In this question, we're talking about infinitely many solutions. So this question here, how many solutions does this equation have? Now by looking at it, we can just rearrange x plus 5 is equal to x plus 5. Well, what could we put in for x that would make this statement true? If I put in a 1 for x, 1 plus 5, 1 plus 5, I get 6 is equal to 6. Infinitely many solutions means that no matter what you put in for x, the statement will always be true. So an equation has infinitely many solutions if after simplifying a equals a. What that means is, if we look down here, 6 is equal to 6. If I put in a 0 for x, 5 equals 5. It's always true. Now for this example, no solutions. If we have x plus 3 is equal to x plus 5. If I try to simplify that by subtracting 3, I get x is equal to x plus 2. Now if I subtract x, I get 0x is equal to 2. Well, we know that anything times 0 is 0, and 0 does not equal 2. So in this part, anything we put in for x, so if we put in a 1 for x, I get 1 plus 3 equals 1 plus 5. So 4 is equal to 6. We know that that doesn't work. 4 does not equal 6. So there is no solution. There is nothing we can put in for x that will make the statement true. Because equality or an equal sign is a statement of truth. What makes a statement true? So an equation has no solutions if after simplifying you get down to something that looks like a equals b, or 4 equals 6, 0 equals 2. They don't, which means there is no solution. There's nothing that will satisfy this equation and make it true. So for you trying, determine whether the following equations have one solution, no solution, or infinitely many solutions, and justify your answer by showing all of your work. In this question, 36 minus 7p is equal to negative 7 times the quantity of p minus 5. I first need to distribute. So I'm left with 36 minus 7p is equal to negative 7p plus 35. So then I'm going to add 7p to both sides. Add 7p to both sides. I'm left with 36 minus 0p is equal to 35. I can subtract 36 from both sides. And I'm left with 0p is equal to negative 1. Well, we know that no matter 0 times anything is 0. And 0 does not equal negative 1. So there's no solution. In this question, 3 plus 5n is equal to 5 times the quantity of n plus 2 minus 7. So I have 3, I'm going to distribute my 5. 3 plus 5n is equal to 5n plus 10 minus 7. 3 plus 5n equals 5n plus 3. So if we just rearrange one of these, 5n plus 3 is equal to 5n plus 3. Does this equal this? Yes, which means it's infinitely many solutions. In this example, 30 plus 6p is equal to 7 times the quantity of p plus 6 minus 5. So I have 30 plus 6p is equal to 7p plus 42 minus 5. 30 plus 6p is equal to 7p plus 37. So now I'm going to subtract 30 from both sides. I'm left with 6p is equal to 7p plus 7. Subtract 7p from both sides. I'm left with negative p is equal to 7. Divide by negative 1. P is equal to negative 7. So this has one solution, because we got our variable is equal to one number. And that is the number that makes the statement true. The only number that makes that statement true.